2e part 2, we have to therefore now show that the curvature k is constant for this family of curves. So just remember that any function f that's differentiable twice, the curvature is given by this function here, k of x, and I've written it out there in blue. So in part 1, 2e part 1, we found the y dx, that was negative x over y, and we found the second derivative was negative r squared over y cubed. So we just need to plug those into our formula and show that it is constant, that it does not depend on x or y. Okay, for this family of curves. Right, so in the numerator, well, the second derivative was negative r squared over y cubed. So we're going to get then negative, the absolute value of negative r squared over y cubed. So this is our function here. And we divide that by 1 plus the first derivative, which was negative x over y, and we square that, and all of that is to the power of 3 over 2. Now the absolute value of negative r squared over y cubed is just r squared over y cubed, and in the denominator, the negative x all squared, well, that just becomes x squared over y squared, and then that whole thing to the power of 3 over 2. And if we write the numerator, just we'll write that out again, then the denominator will write it a bit clearer. So I'm going to write it as y squared, so times that 1 by y squared, the numerator and denominator, plus x squared all over y squared, and that is the power of 3 over 2. And now we can simplify that a bit, because this part here, the y squared plus x squared, well, remember our function that we're given the family of curves was y is equal to the square root of r squared minus x squared. So therefore, if I square both sides and move the x over, I get y squared plus x squared is equal to r squared. So therefore, I can write that denominator a bit more simply, more simple. Okay, so now we get y squared over y cubed. Just scroll down a bit here. All over, so y squared plus x squared we said was r squared, so I get r squared over y squared to the power of 3 over 2, which equals r squared over y cubed. And just using the rules of indices there, r squared to the power of 3 over 2 is just r cubed, and then y squared to the power of 3 over 2 is y cubed. So we're dividing r squared over y cubed by r cubed over y cubed. So we'll just multiply by the reciprocal. So I get y squared over y cubed times y cubed over r cubed. Y's are going to cancel. R squared and r cubed simplifies to 1 over r. So in conclusion then, the curvature of x is going to be 1 over r for this family of curves, which is constant. Okay, so I'll just make a note there. That is now constant. So we have shown the curvature k is constant for this family of curves.